Mercury, named after the Roman mythology, the messenger of the gods, because its fast speed compared to other planets. Why is that? And can it hold life as we know? Hello my friends, welcome to the Horizon Seeker. In this spacecraft, we will adventure throughout the universe and talk about its celestial bodies. To do so, this ship defies the laws of physics by going beyond the speed of light, as well as time traveling into the past and future. My name is Stradivari, and in this journey we will talk about Mercury, the closest planet to the Sun. What kind of planet is Mercury? Does it have atmosphere and moons? How long is a day there and a year? What would it be like to live there? So come on board and stay with me until the end. Okay, so let's take the cockpit. If you didn't see my previous trips, don't forget to check them after we finish this trip. Oh, and don't forget to like the video, subscribe to the channel and activate the bell so YouTube can tell you when we are ready to go to our next trip. So my friends, let's use our fast speed to see Mercury's orbit. Let's turn on our ship's screen view and see planets' orbits and names. Mercury is named after the messenger of the gods from the Roman mythology. Roman Mercury had wings on his helmet and shoes, and he could travel really fast. It was named like that because the planet is the fastest on the solar system. This is Mercury's orbit. You can see that it's elliptical or egg shape. Because of that and of its slow rotation, the morning sun appears to rise briefly, stops for a little, and then continues on its way, watching from some parts of the planet's surface. The same happens at sunset. I will show you at the end of this trip. Let's increase time to see how fast Mercury moves compared to other planets. Because of its proximity to the Sun, a year in Mercury takes only 88 Earth days. However, it rotates slowly compared to Earth. It takes 59 Earth days for 1 day in Mercury. So, if we live in Mercury, it will take only 1.5 days to complete a year. Now let's track Mercury on our ship's computer. There it is. Let's fly to the planet faster than the speed of light. Let's open our internal computer simulator that we will call ICS from now on. Mercury was formed around the same time as Earth, about 4.5 billion years ago. Before that, the solar system was a cloud of gas and dust known as a solar nebula. After some time, higher concentration of the nebula's elements started to form clumps. After some more time, one clump dominates and heats up. When its temperature reaches 10 million degrees Celsius, nuclear fission begins, forming our Sun. Then the planets started to be formed from the remains of the nebula. Mercury was one of them. Recent studies revealed that the radius of its solid iron core is about 2,000 kilometers, about half of its entire core, which is significantly more massive than the rest of the planet, about 85% of it. Just to compare, Earth's core is about 54% of the planet's size. Mercury's outer shell, that is the mantle and the crust, is only about 400 kilometers thick. Mercury is the smallest planet in our solar system. It is 2.6 times smaller than Earth and a little bigger than the Moon. Its diameter is 4,880 kilometers. That's about the distance from New York to the coast of Ireland. If we consider moons, Mercury is even smaller than Ganymede, one of Jupiter's moons, and Titan, one of Saturn's moons. The average distance from the Sun is 58 million kilometers, about 0.4 astronomical unit. 1 astronomical unit is the average distance between Earth and Sun. That is exactly, according to NASA, 149,597,870.7 kilometers. Mercury is the closest planet to the Sun, although it is not the hottest. Because it has a very thin atmosphere, the temperature varies from 430 degrees Celsius on sunlight to minus 180 degrees Celsius at night. The hottest planet is his neighbor Venus, that has a thick atmosphere, which helps hold the temperature on the planet, like a greenhouse. As well as Venus, Earth and Mars, Mercury is a terrestrial planet. Just to understand, there are different criteria to classify planets. Here are the 4 types of planets classified by NASA on our solar system. Terrestrial planets like Mercury, Venus, Earth and Mars. Gas giants like Jupiter and Saturn. Ice giants like Uranus and Neptune. And dwarf planets like Ceres, that is on the asteroid belt between Mars and Jupiter, Pluto, Haumea, Makemake, and Eris at the end of the solar system. We all know from our science books, and for common sense, that our closest neighbor is Venus. That is right if we put all planets on a straight line or if we calculate using only the planet's average distance. Although recent calculations and studies made by scientists and published in 2019 using also the time variable as the time Mercury spends closest to Earth, suggests that Mercury is Earth's closest planet. That happens because Venus has a lower orbit, and so most of the time it is far away on the other side of the Sun, while Mercury, that has a faster orbit, gets closer to Earth more often. Also because of that, Mercury is actually the closest planet to all other planets on the solar system, as we can see in this line. You can pause the video and compare all distances. For more information about it, check the links on the description. Let's have a look on Mercury's surface. As we can see, it is much like our Moon, solid, covered with craters and with a thin atmosphere or exosphere. Also, the planet has no moon or ring. Now, did you know we sent missions to Mercury? The planet is hard to study because it is so close to the Sun, and we never sent people there. However, we sent spacecrafts. Let's open our ICS again. Mariner 10, sent by the United States to fly by the planet 3 times, one in 1974 and 2 in 1975, imaged about 45% of its surface. According to NASA, there is a list of first accomplishments achieved by Mariner 10, which are the first spacecraft sent to study Mercury, the first spacecraft to use the gravity of one planet, in this case Venus, to reach another, the first spacecraft to return data on a long-period comet, the first mission to explore 2 planets, Mercury and Venus, during a single mission, the first spacecraft to use a gravity assist to change its flight path, the first spacecraft to return to its target after an initial encounter, in 1974 and 1975. The first probe to use the solar wind as a major means of spacecraft orientation during flight. Mariner 10 sent back more than 2,700 pictures of Mercury's surface. This is a computer photo mosaic of the southern hemisphere created by computer program using the images sent by Mariner 10. After that, more than 30 years, NASA sent Messenger that flew by Mercury in 2008 and 2009 and then started to orbit the planet in 2011 until crashed on its surface on 2015. It helped scientists to study the planet's core, atmosphere, craters, magnetic field, that helps to understand our own planet and the relation between the cooling of the planet's core with changes to the magnetic field. The European and Japanese space agencies launched their first mission to explore Mercury, BPI Colombo, in 2018, scheduled to reach the planet in 2024. If we use our current fastest spacecraft, other than the Horizon Seeker of course, which is NASA's Parker Solar Probe that is believed to reach up to 700,000 km per hour in 2024 when orbiting the Sun, it would take about 5.5 days to get to Mercury from Earth, considering the distance between our planets of an average 91.7 million kilometers, or 0.61 astronomical unit. But that would be like we do with the Horizon Seeker, going on a straight line and making a tremendous break to stop right on the planet. That's not what happens with current spacecrafts that we actually have on Earth. Let's see the European Space Agency simulation of BPI Colombo's journey to Mercury. BPI Colombo, that was sent to Mercury in 2018, will take 7 years to start orbiting Mercury because it needs to reach the planet traveling slowly enough to be captured by Mercury's gravity, also using the gravity of other planets like Venus. And by arriving in Mercury, BPI Colombo will have to slow down, which is very complicated to do in the vacuum of space. Now let's talk about life on the planet Mercury. Because of the high temperatures that can reach up to 430 degrees Celsius, it seems unlikely that the planet can hold life as we know. But a group of scientists brought up the possibility that some parts below the surface of Mercury could be able to generate prebiotic chemistry and maybe some simple forms of life in the past. According to the theory published in the Nature's Journal Scientific Reports, there are chaotic terrains that were not caused by earthquakes, but by the collapse of the terrain. That's because there may have been volatiles, particularly water, underground, that turned into gas as a result of intrusion of magma below, which caused the terrain above to collapse into a jumbled mass. So, because these volatiles could be water, there is a light possibility that there were microbiotic life on Mercury before the magma evaporated it all. Now let's talk about the hypothesis that we decide to build a base on Mercury. How could it be to live there? First of all, there is a very thin atmosphere, like our moons called exosphere. We can't breathe there without a suit. As the temperature changes from 430 degrees Celsius during the day to minus 180 degrees Celsius at night, we would have to use a suit that can hold those temperatures. Also, the solar radiation is extreme, so again we need a suit that can hold it. During the Messenger mission, it found frozen water on the poles of Mercury. The poles don't suffer as much as the other parts of the planet to sun's heat. So, to build a base on the planet, we could do it as close as we can to the poles to get water, but preferably not exactly on the poles, because it is always dark and freezing. Now, let's land on the planet. Look into the sky. Because Mercury has a very thin atmosphere, the sky would be dark, different from the blue sky that we see on Earth. Also, because of its proximity to the Sun, our star would be about 3 times bigger than what we see on Earth and 7 times brighter. Also, because of thin atmosphere, the stars wouldn't twinkle like what we see from Earth, but they would look like boring little points. Also, there is no clouds, winds, rain, or volcanoes, but as our moon, Mercury, is hit by all sizes of asteroids and meteoroids, as its atmosphere is not thick enough to burn them, like what happens on Earth. Oh, and there is also earthquakes because of the tidal forces from the Sun that pulls Mercury's outer molten core like what the Moon does to our oceans, creating the tides. The gravity of Mercury is about 38% of Earth's gravity, so we could jump 3 times higher, and also the objects would be 3 times lighter. Let's have a look on the path of the Sun. First, let's go back in time to put the Sun on a rising point. Okay, now let's go forward in time. Now, because of Mercury's fast and slow rotation, we will see that just after the Sun rises, looks like it stays on the same position for a long period and then restarts to move towards the sunset. See? From Mercury's perspective, the Sun is still on the same position. Now, it restarts moving. So, my friends, as we could see, there can be no life as we know in Mercury unless we use a very high-tech suit to support the extreme environment of the planet. So, as we go back to Earth, if you enjoyed this trip and also want more of it, like this video, subscribe to the channel and activate the bell so YouTube will tell you when our next trip is ready to go. Thank you and see you next time.